Okay, so our learning goal today over here states, I can solve rate problems using proportions. So we're going to set up proportions to help us problem solve. We're going to have sometimes lots of information to dissect through. Tell me something about what you just read in number 1. Just what is all that about? Don't worry about the question underneath. Tell me what all that is about. What is something that you determined by reading all of that? What's one thing, Danny? Okay. Is this one specific airline? Yes or no? Is it one specific airline? Look at your papers. I thought it was.
Oh, yeah.
Oh, yeah.
Isn't it called Central Airlines? And where are they flying out of? Atlanta. So all of the flights shown in the table are what? From Atlanta to different cities throughout the United States, right? Okay, so we have the Central Airlines. They're flying from Atlanta because that's where they're based. So they're flying out of Atlanta and they're showing a number of cities that they fly to. What else are they giving us? What other kind of information are they giving us? Okay? Okay, the number of miles it is from Atlanta to that destination, and then the number of hours it takes them to get there, the flight. Okay? And what did they say? Did they say something about doing some rounding or something? Anybody catch that? Harlan?
Flight times have been rounded to the nearest hour.
Yeah, so the flight times have been rounded to the nearest hour, so just in case you've ever, like flown from Atlanta to one of these cities and you're thinking, no, this is not accurate. It's, and it's been rounded. Plus, sometimes, I don't know if you've ever experienced, how many of you have actually flown on a commercial airline? Yeah, okay. And when you fly on them, sometimes it says it's going to take a certain amount of time to get there. And there will be times it'll take longer than they said, and there will be times it'll take less than they said, depending on, how fast they fly the plane and a few other factors, okay? So, what else did they tell us that maybe it's important, but maybe not so important when we're going to be problem solving? Is there anything else that they gave you in there that you're like, you might get confused by? Okay.
Thinking versus the distance they flew is 1,950 miles.
Okay, the longest distance they fly is 1,950 miles. Okay, so, that's information for us, right? So if there was any question about the longest distance, that would be helpful. Is there anything else they tell us that maybe or maybe not we'll use? Sammy?
Most flights take under 3 hours.
Okay, that most flights take under 3 hours. Okay, so maybe, maybe not, we'll use that. Okay, is there anything else? Ikea.
Most flights across the United States takes as long as 6 hours.
Okay, and so it shows that flights can take as long as, not most of them take it, but they can take as long as 6 hours, right? So there's another piece of information we may or may not use. So my point I'm trying to make to you right now is this. There's a whole bunch of information there. We have to learn, here's how we will get good at word problems. You have to learn how to dissect them and decide what am I going to need to use here? And not just because there's a bunch of numbers, say, well, I'll just put this number here and that number there and this one here, and hopefully it'll just all work out. We can't do that. We have to problem solve through it. Okay, so now we have this table. We've talked about all of the things that are showing up in it. Now we're going to go to our question. Let's circle this. If it takes 3 hours to fly from Atlanta to Denver, how far does the plane fly in 1 hour? Well, if we just use that question right there, if we did not do anything else, would we have enough information? That's all we focus on is the question. If it takes 3 hours to fly from Atlanta to Denver, how far does the plane fly in 1 hour? They give us enough information right there? No. What else do we need to know? How many miles was this flight? So we're gonna go up to the table and we're gonna look for from Atlanta to Denver and we're gonna circle that in our table. And sure enough, in the table it does say it took 3 hours, doesn't it? And now the table gives us some more information that will be helpful. It also tells us how far it is. So how far is it from Atlanta to Denver? Class? 1,000?
1,200 miles.
1,200 miles. Okay, so what we're supposed to find out is how far does the plane fly in 1 hour? So here's what we're gonna do. What makes more sense, hours per mile or miles per hour? Miles per hour. So we're gonna set up a proportion. Our ratio, the Atlanta to Denver, they went 1,200 miles in 3 hours. They want to know how far the plane went in 1 hour. Well, in the other ratio, we have to have the same comparison going on, miles to hours. So we'll put 1 hour, and it says how far. Well, sure enough, we're solving for how many miles, so we'll put an X for the miles. And now we'll use our horizontal or vertical strategy to solve it. So we need to go from 1,200 to X. So the question is it friendly to go from 3 to 1? Okay, what do we have to do, class? Divide by 3. So show that you're going to divide by 3, which means up here we're going to also have to divide by 3. So over here we're writing our problem up. 1,200 divided by 3 equals X. And then we'll do the math. How many 3's in 12? 4, and then we still have what behind that? 2 zeros, so it's 400, isn't it? X equals 400. Okay. Now, here's what we're going to do, though. We're not going to put a label there. We're going to go off and we're going to write what we just found. It says, how far does the plane fly in 1 hour? We're going to say 400 miles in 1 hour. And we're not going to do any abbreviating there. 400 miles in 1 hour. So we know that after an hour in the air, the plane had covered 400 miles. Can anybody else tell me what else that tells us? Because that's called a rate. Can anybody else tell me what information that gives us? Sylvia? So it gives us how fast the plane is traveling, doesn't it? 400 miles per hour. The plane is flying at a speed of 400 miles per hour because we have it as a rate, miles, hours, and it's per 1 hour. So this also tells us how fast the plane is going. Okay, let's go on to number 2. Who would like to read that out loud for us? Nice and loud and clear, please. Hey, Harley.
Beaver Dam is one of the largest dams in the United States. It is 35 miles from water.
How far?
34 miles. And the temperature in the summer can get as hot as 115 degrees Fahrenheit. The water is released from behind the dam to make
Electricity.
The water flows from the dam at a rate of 10,000 cubic feet every 5 seconds. How many cubic feet of water flow per second?
Anybody ever been to Hoover Dam? Okay, all this information in here is actually quite true because I had a son who lived down there for 7 years, so I have visited Hoover Dam. And it is about 34 miles from Las Vegas, and it does get really hot there. 115 degrees is nothing for them. So, in the summertime, of course. So, what do we need? Do we need to worry about the fact that it's 34 miles from Las Vegas? Is that important? Not really. Does it matter that it gets as hot as 115 degrees there? No, that isn't really important either. They're asking how many cubic feet of water, so let's circle that, that's our question. How many cubic feet of water flow per second? Well, did they give us some information that'll help us figure that out?
Yeah.
What do we know? Katie?
Where it says that over 10,000 cubic feet per 5 seconds.
Okay, so let's make that into a ratio. 10,000 and cubic feet we can call CUFT. And every 5 seconds we can call SEC. And then we set up the other ratio. How many cubic feet? Oh, they're asking us to solve for how many cubic feet. So X CUFT, X cubic feet per second. What's going downstairs?
1 second.
1 second. Okay. Okay, the question is, what do we have to do? Horizontal, vertical, let's see. Should we see, we have to go this way. Would that be? Let's check that out. Is that friendly?
Yeah.
Okay. What do we do?
Divide by 5.
Divide by 5, okay. I don't know what I was making there. Okay, so we're gonna come off to the side and say what? What's our equation gonna be?
10,000 divided by 5.
10,000 divided by 5 equals X. I almost got you. Well, we can take 5 into 10, can't we? How many times? 2. And what are we going to attach to that 2?
3 zeros.
3 zeros. So X equals 2,000. I love that we don't just automatically think the calculator has to do it for us. Because we're good, aren't we? Okay, how are we going to finish this answer now? What are we going to say? What are we going to say? Sammy?
2,000 cubic feet per second.
2,000 cubic, now we're going to write out the words, cubic feet per second. There's our final answer. It's a unit rate. It tells us the water is flowing at that rate, 2,000 cubic feet every second. Can somebody show me what a cubic foot looks like? Can you give me a visual? What can you visualize? Cube? Yeah, got a cube. Okay, well what does a cubic foot mean?
Using a cube to measure feet.
Okay. And what would the dimensions of the cube be?
Square. Cubic.
1 foot by 1 foot by 1 foot would be 1 foot. My arm's a little from my elbow here to the tip of my fingers. That's probably more than a ruler. So we'll go from my Fitbit to my elbow. It would be that many, that much high. Can't put my hand into it, and then it's going to be that much deep. So what a cubic foot looks something like this.
Yeah.
So there's 2,000 of those going over that dam every what?
Second.
Second. Is that a lot of water?
Yeah.
Seems like it would be, doesn't it? Okay. Okay, let's go to the back side. Okay, what I want you to do is I want you to read through that problem and I want you to decide what do you have to set up to problem solve this one. So all I want is the setup. Remember, most likely they're giving us a whole bunch of extra information. Okay, we're not solving. Look at me when you kind of set up, please. Don't leave me wondering what to do. You guys think they can start us off? Anybody? Okay, so we got, is that something that's gonna be, the fact that the pickup can carry away 2,000 pounds a trip, is that gonna be important in finding how much it's gonna cost Craig for the gravel? What do you think? Do you think that's an important piece of information?
Mm.
Okay, well, let's see. Anything else that, Tammy?
Oh, the gravel and the gravel.
The gravel in the table? Yeah, it's not quite a graph, but it's a diagram, so. The gravel, so that's kind of important stuff to take out of there, that would be the place we need to zero in on the table, you're saying? Okay. Because it says he needs 75 pounds of gravel to repave a driveway. So gravel is what he's going to get. How much will it cost for the gravel? So what can we do now? Number two ratios set equal to each other with a variable standing in for the unknown. Harley, what do you think?
15 pounds of gravel
So 50 pounds over $4, okay.
and
I'm sorry, what?
then 75 pounds. And extra
Okay, look that over, class. What do you think? You think that might work? We're comparing pounds to dollars. In the table it says 50 pounds of gravel will cost $4. Well, Craig doesn't want 50 pounds, he wants 75 pounds. So the question is, how much will it cost him? Think it's a good setup? Okay. Well then, next thing we gotta do is decide, is there a friendly way to get there? So we could either go like this. How friendly is that?
No.
Not very friendly. Okay, well then we could do this. How friendly is that? Even worse, right? Yeah. So, what do you think we're gonna do then? What if it's not friendly? What are we gonna do then? Arlie? Simplify. Well, what can be simplified there? I agree. Simplifying would be an awesome thing to try. Well, can we simplify 75 over x? No, so our only choice is really the 50 over 4. So let's see if we can simplify that. What goes into both 50 and 4? Because they're even numbers. 2. So 50 over 4 can be renamed as, you don't know what half of 50 is? Okay, Ikea? 25 over 2. Oh, so now what we'll do is we're going to say, okay, let's start this problem over now. Let's do 25 pounds over $2 and set that equal to the 75 pounds that Craig wants over X dollars. Now is it friendlier? Well, let's see. Remember, we got to go from here to here. So can we go from there to there? Yeah, those are kind of nice numbers, aren't they? Okay, what do we have to do to get from 25 to 75? Take it times 3. Oh, my multiplication dot isn't looking very good there. Let's try again. And so I'm going to do the same thing down here. So now our equation is 2 times 3 equals x. And 2 times 3 is 6. So how are we gonna answer this question? What did we just find out? We just find. I gotta hear some other voices today, come on, exercise those vocal cords. Tyler,
$6 is gonna be the cost of 75 pounds.
okay, $6 for 75 pounds of gravel. $6 for 75 pounds of gravel. It's $4 for 50 pounds. Can you give me another one that you know? So it's 6 pounds for $6 gets you 75 pounds. $4 gets you 50 pounds. Get it? $2 gets you 25 pounds. So all of those things are representing what's going on in this problem. And notice, did we use the 2,000 pounds? Did that matter? No, it didn't happen to matter in this case, okay? So again, there's lots of information we gotta dissect through and determine if we even need it. Okay, let's do this one quickly and then we'll be done. A snowboarder starts at the top of Mount Harper and is traveling down the mountain through different runs. The first run is bumpy and the run is only 50 feet wide at one point. This slows everyone down so skiers don't crash into each other. Well, I would probably still crash into a skier, but the fastest part of the run is 1,200 yards long and is straight downhill. I'm avoiding that one. This is where the snowboarder really picks up speed. At one point, the snowboarder is traveling 14 feet every 3 seconds. How far does the snowboarder travel in 1 minute? How far does the snowboarder travel in 1 minute? So how do you feel about the fact that there's that spot where the run is 50 feet wide? Does it matter? Not in what we're going to be looking for. Does it matter that the fastest part is 1,200 yards long? No, just that we're going to avoid it, or at least I am. Wade?
I wanted to set up the problem.
Okay, you're ready to set up the problem for me. Okay, what are you going to do?
14 feet over 3 seconds is equal to x over 60 seconds.
X feet? Is it?
Yeah, x feet.
Yeah, we
over
give
60.
everything a label in our setup. Oh, that's interesting. I don't see a 60 in this problem anywhere. I see a 14, I see a 3.
1 minute is 60 seconds.
Oh, is it important that we're comparing like things? Yeah, if we would have put a 1 down there, would we have been comparing the same things? Feet to seconds, feet to minutes, would that have worked? No. So Wade was wise. He said, I gotta change that minute into seconds. So if off to the side here, you need to put, this is 60 seconds. 1 minute has 60 seconds in it. It's important that we rename it. Okay. Gotta go from 14 to X, 3 to 60. That friendly? Harley says no.
14, no, 3 to 14.
3 to 14 is friendlier?
3 times 4.
Oh, what's 3 times 4?
12.
Darn, I wish it was, but it isn't. Okay. So I'm thinking we might want to stick with this one because can we do any simplifying of 14 thirds even?
No.
No, so we're gonna have to make this work, folks. 3 to 60. What do we have to do?
Take it times 20.
Multiply by 20. 3 20s is 60. So we have to do the same thing to that 14. So 14 times 20 equals X. Now, we don't need a calculator for this either because we are so smart. We don't have to worry about the 0 on there. We can say 2 14s is what? 20? Well, it is in the 20s, but it's not 20. 8? Well, okay, if you need to do this, guys, just go over here and do it. I was just trying to get you to do it in your head. Go ahead, just multiply it out, Sierra. 280, because 2 14s is 28, and then attach a 0 behind it. So X equals 280. Okay, so that's what, 280
Feet.
feet, F-E-E-T now, in
1 minute.
1 minute, that was the question. How far will the snowboarder travel in 1 minute? 280 feet. Okay. So you're gonna be able to do this on your own now? You're doing this in your homework. You got it? Okay, cool. Anybody need this up here any longer? Okay, you do not need loose leaf today.